This is our third lesson. It says lesson 4 at the top here. This is our third lesson from chapter 13. And the question we're going to look at today is we're going to look at the angle between a plane and a vector. Now before, what we've looked at is we've looked at angles between vectors when we use the dot product to find that. And the other thing we've looked at with regards to planes is how we find a normal to a plane. Now the key thing about a normal is that it's actually a vector. So as we know how to find the angle between vectors, we're not going to actually find the angle between a plane and a vector directly. We're going to find the angle between a vector and a vector, and then you use that to actually help us. So we're going to find two direction vectors that lie on the plane. We're going to find a common perpendicular, which is a skill we learned in a previous lesson. Then we're going to find the angle between the direction vector and this normal, and then we're going to use that answer to help us actually find out what the correct angle is for this question. So if you actually look at question 10 from the exercise today, which is 13b, then this is what we're actually doing. Now the roof, this is actually a plane, so this is a three-dimensional object. The tunnel is going to be our two-dimensional, it's going to be a specific direction, and our normal is also going to be a vector as well. So we can find this angle, but we can't find this angle directly. But we should be able to make a connection between these two things, because we know that this whole angle here is 90 degrees, because this is a normal, and that's the definition for a normal. So, first of all, we should work out A to B and A to C. And I've given you the vectors here so you can see. You can either do this, take away this, or you can just say how do you get from this number to this number. So from negative 19 to negative 20, we subtract 1. Once we've found those two vectors, I would go ahead and write them side by side. That's what we want to do is we want to do the common normal. So when we do the common normal, cover up that first row, so the 5 and the 0, and then we do cross multiplication. 0 times negative 3, 0. Subtract negative 1 times 5. So 0 take away negative 5 is 5. Cover up the middle row, go down 1. Negative 1 times 0. Subtract 5 times negative 3. So 0 take away negative 15 is 15. And for the bottom row, we go down, which loops back to the top. 5 times negative 3 is negative 15. Times by, 5 times 5 is 25, times by 0 times 0 is 0, and 25 take away 0 is 25. Now if we go back to the previous section, it says we're going to find two direction vectors of the plane, we're going to find a common perpendicular, that's what I just did, and then we're going to find the angle between the direction vector and this normal. So this we can actually simplify. With this just being a direction vector, we could take a multiple out here and it would still be the same direction vector. So we could say for this one, this is 1, 3, 5. And that's actually what we're going to do. Now, the two vectors we're looking for in the question, and you'll have to check this in the book, this said negative I plus 2j minus 20k. We're going to find the angle between the normal and the tunnel. So to do that, we're going to use the formula for the dot product. P dot Q equals absolute value P, absolute value Q cosine theta. So we can find the length of this using 3D Pythagoras. We can also work out the dot product by multiplying these elements and adding them together. And you should find this. 1 times negative 1 is negative 1. 3 times 2 is 6. 5 times negative 20 is negative 100. And if we add up all these together, we should get negative 95. The length of this, 1 squared plus 3 squared plus 5 squared, all square rooted. And same thing here, negative 1 squared plus 2 squared plus negative 20 squared, all square rooted is 405. And we get an angle of 403. Now step 4 says we've got to go back and look at the picture to see what actually happened here. So here is our original plane. Here is our normal at 90 degrees, and then here was the tunnel somewhere between them. And the angle of 143, well, as it's an obtuse angle, this here must be 143. So in other words, this angle there must be 53. And that's actually what the answer is for this question. This is the plane, and this is the tunnel. Or the other way we could think of it is, if this is 143 here, that means that this angle here is 37. And as these two angles add up to 90, it means that this must be 53. So that's our other way of thinking of these questions. This is a type of question I would expect you to get on the ACE exam, because look back at all the skills you've actually done for this question. We had to find direction vectors, we had to find a common normal, we also had to find the angle between something, so it was a refresher on the dot product for the first part, and also had to find the lengths of vectors. And also the last part, just to make sure you understand what you're actually calculating. So go back through those steps, make sure you can understand them, and then you should be ready to make a start on the miscellaneous exercise.